Good morning. We are at the top of the hour, so we're starting. Welcome to this third webinar from the webinar series sponsored by the National Academies of Sciences, Engineering, and Medicine, Approaches to Assessing Intake of Food and Dietary Supplements in Pregnant Women and Children ages 2 to 11. I want to start by thanking the sponsors of this webinar series, the NIH Office of Dietary Supplements, especially Nancy Pottishman and Jamie Gachet. I'd also like to thank my colleagues from the Planning Committee, whose names are listed here. I am Donna DeBelia from the University of Colorado Anschutz Medical Campus. This is the third seminar or webinar in a series of 4. We already had the first and second one last week or 2 weeks ago and Monday, and we'll have another one next Monday on issues spanning all the life stages discussed in the 3 webinars. This slide just shows what's going to happen today. After my introductory remarks, we're going to hear from the first 2 experts in the field, Emma Foster from Newcastle University on methods to collect dietary intake in children ages 6 to 11, and then Tracy Beckelman from the University of Colorado on a comparison between remote food photography and ASA 24s. After these 2 presentations, we'll have a 20-minute session of Q&As from committee members and sponsors, followed right away from 2 more talks from experts in the field, Tom Baranowski from Baylor and Wei Pern from University of Colorado, again followed by a 20-minute Q&A session moderated by my colleague from the University of Colorado, Dr. Steve Daniels. Following this, we'll have a panel discussion with the audience for about 15 minutes, again moderated by Steve Daniels. And then we'll end up with wrap-up thoughts from Cheryl Anderson, the chair of the Planning Committee. This is just a few housekeeping issues. During the panel discussion with the audience, we invite the audience to send your questions via the Zoom Q&A feature so we can organize an engaging conversation. All the presentations in this webinar have been and will be recorded and have been or will be published on the website shown here. I'm going to start with a few remarks about challenges and opportunities related to dietary assessment in children in this age range. I know some of your questions that you've already submitted ask about what are the challenges, what are the opportunities. So some of the challenges are specific to this life stage. Some are actually pertaining to all life stages that we are discussing in this series. One of the first things about this age range is that this is a very heterogeneous age group. I would call it a transitional age group in terms of methods of assessing dietary intake by recall. And this is due to the heterogeneity in age-related cognitive aspects characterizing this age range. So before ages 7 to 8, when we collect diet by recall, we rely on parental recall because very young children, as you know, are not able to remember what they eat. And so we've discussed at the last seminar the issue of parental recall, multiple caregivers, multiple venues, schools, after-school programs, etc. After ages 7 to 8, the field believes that the cognitive abilities of children are as such that they can report on their own dietary intake. But again, there is heterogeneity. And we're relying on children's memory, on their ability to estimate portion sizes, and there's a lot of heterogeneity in this age group, as well as throughout childhood and adolescence. So these cognitive aspects have implications for the design of optimal tools that might be specific to this age group. And there is variability in nutrient intake in this age range. Even within this age range, there was a lot of variability, but for sure, children's diet in this age range is much more variable than adult diet, at least twofold greater variability in this age range than in adults. And this variability is actually even higher for nutrients that are consumed occasionally, such as vitamins, than for those that are consumed habitually. And this has implications for the number of recalls, building appropriate food databases, so on and so forth. Then tracking of nutrient intake over time, which we know in the adult literature is pretty good. There's little evidence that there's tracking in this age range, which has implications for the most appropriate life stage target intervention, nutrition interventions. And all these issues lead to issues surrounding validity and accuracy of diet reports. And we all know that they are likely biased, usually in the direction of underreporting, and the magnitude of bias increases with age, with weight status of child and or parent, the so-called social desirability bias. And the magnitude of the bias varies with the dietary assessment method, although we don't see a lot of variation with sex. So these biased or invalid diet reporting influences or biases, the associations between diet intake and health outcomes. And I wanted to very quickly give you an example of some of these challenges with data from one of our studies in Colorado, the Epoch study. And this example explores the relationship between childhood sugar intake around the age of 10 and adolescents' hepatic fat later on in adolescence measured by MRI. So the measurement of the outcome is pretty precise. The measurement of childhood sugar intake was conducted with a food frequency questionnaire, which is validated for this age range. The hypothesis was that we will see a positive association because that makes biological sense, and there is evidence for that from animal studies. And this is what we saw. Here on the x-axis, you see the percent of sugar intake. And on the y-axis, you see the log hepatic fat values. And the relationship between the two is inverse among 384 participants and statistically significant, which does not make biological sense. So we then thought that this might be due to the issues related to accuracy of diet reporting in the study, and that there might have been underreporting among our participants. So we assessed we estimated the amount of underreporting using the Goldberg method, which compares the ratio of observed energy intake to estimated energy expenditure via basal metabolic rate, to the lower limit of the 95% confidence limit of a physical activity level constant. And we did that with the formulas shown here. And then we looked back at the characteristics of our participants classified as acceptable reporters or underreporters using this method. And about 25% of our participants were classified as underreporters with this method. And underreporters were more likely to be of Hispanic race ethnicity, had a higher BMI Z-score, and more visceral and subcutaneous fat. And also, they were offspring of mothers with a higher pre-pregnancy body mass index or obesity status. In terms of nutrient intakes, the underreporters tended to underreport their total energy intake, their percent intake from sugars and animal proteins, and they tended to overreport their intake from fibers. When we excluded the underreporters from our sample and reassessed the association between sugar intake and hepatic fat among now 295 participants, the association still trended in the implausible negative direction, but it was no longer significant. We believe there's still issues surrounding inaccurate diet reporting of sugar intake in this study that we're now planning to assess with different methods, such as biomarkers. So these challenges also speak about potential opportunities regarding diet assessment in this age group that I hope we will be hearing from our speakers today, including touching on issues on how to improve the diet recall tools, how many diet recalls we need, whether we should use multiple types of diet recall methods, whether we should incorporate recall methods with technology-based methods, whether we should validate and how, is there a role for biomarkers? And going back to the most important feature of this discussion, in my opinion, is that assessment tools should match the research question. In the example I just gave, the research question was an afterthought. It was the study was not specifically designed to assess this association. Had we thought about this before, we might have designed the study differently. I'm going to now go into reintroducing the four speakers. They're listed here, and give the baton to Dr. Emma Foster from Newcastle, and she will talk about methods to collect dietary intake in this age group. Emma?
Thank you. I'm just getting the share screen ready. It's telling me that I can't share. Hang on.
Yeah, we're seeing your slides, Emma.
You've got them. Okay, great. Okay, so first of all, thank you to the Planning Committee for inviting me to speak as part of this webinar series. I'm Emma Foster. I'm from Newcastle, which is in the northeast of England, and I'm going to be presenting research from my time at Newcastle University. I'll start by talking about some of the challenges in assessing dietary intake in children aged 6 to 11, and then I'll go on to give some examples of methods that we've used with this age group. There are a number of different methods of assessing intake. So in selecting the best method, you need to think about the question that you want to answer. So are you interested in intake of a particular nutrient or food? If you're interested in intake of oily fish, for example, you might not need to measure total intake. Whereas for energy and macronutrient intake, you will need to measure intake of all foods and drinks. You need to think about the time frame. So, for example, are you interested in usual or habitual intake or change following an intervention? And inevitably, the choice of method is going to depend on the budget that's available. In general, there's an offset between accuracy and participant burden, with the most accurate methods requiring the most effort from respondents. And as the burden of the methods increases, so generally does the cost, so does the recruitment bias, because only a certain type of person is willing to weigh and record all the foods that they eat. And the likelihood that people will make changes to their intake because of the recording method also goes up. So instead of making a meal from scratch where they would have to weigh all the ingredients, people may put a shop bought pizza in the oven because it's much easier to record. Measuring dietary intake of people of any age is difficult, but with young children it's particularly challenging. They may not be aware of the names of many of the foods that they're eating. They spend a lot more time away from home with several people responsible for preparing food for them. And they're often focused on other things while eating, so they're not particularly paying attention to what they ate while they're eating it, let alone committing that to memory. And the motivation to take part in a study or interest in food will vary, with some children seeing lunch as something that they just need to get out of the way before they can go out and play. Measuring usual intake can be a challenge for children who may go through phases of having favourite foods or meals. And social desirability bias may be heightened because parents are going to want to be seen to be providing a healthy diet for their child. The children themselves are not immune either. I've had children come up and say to me, is this the study where you get paid to eat healthily for a week? When what we really wanted was to measure their usual intake. Then there's the issue of leftovers, spillages, and swaps. Whereas adults tend to choose the foods that they like and portions that they know they'll eat, children are often served more than they want. And the issue of leftovers is further complicated by social desirability bias, in that if you ask a child, did you leave any of your food? They know that the correct answer is no, I ate it all. So now I would like to share with you some of the methods that we've used and developed for use with children in our research at Newcastle University. Firstly, for a school-based fruit and vegetable intervention in children aged 4 to 11 years. Here we wanted to pick up changes in intake following the intervention, and we were comparing intervention and control schools. We used a hybrid method, which was a combination of a food diary and a food frequency questionnaire. And this was completed by parents for foods at home. And in school, it was completed by research observers. The diary was divided into 6 time slots, and these were based on peaks in energy intake in this group. And the most commonly consumed foods in each time slot were included as tick boxes, and these were linked via a database to age and gender specific portion sizes. There was also space to enter any foods which were consumed but not on the list. We did a comparison of this method against 4-day weighed intakes, and we found that mean intakes of fruit were within 3% of that recorded in the diary, and the mean fruit and vegetable intakes were almost identical. So this method proved appropriate for assessing change at the population level. For a study looking at children's exposure to contaminants from food packaging, we needed really detailed individual level data on the foods consumed, including accurate amounts and details of the size and type of packaging. For this study, we asked parents and carers to complete a weighed food diary for the foods eaten at home, and we had trained observers go in and weigh and record all the foods that children had whilst they were at school. We've also used an estimated weight food diary completed by the parent and child in a number of studies. So this is where they write down the foods and drinks that they've eaten, but the estimates of portion size are done at an interview at the end of the recording period. With younger children, we've used the write and draw method, where children can draw the foods that they're eating away from home, and these images then serve as a reminder when going through the diary later with the parent. When interviewing children themselves, if you do a combined young child and parental interview, it's important to focus on the things that children take notice of. So children may not have or may not know the specific names for foods or details about cooking methods, but they may be able to tell you about the texture or the colour of the food, details about the food packaging, or describe the cooking method. For example, it was brown bread with bits in it, would be a description for granary bread, or he put them inside the oven might be a response to how were your potatoes cooked. Initially, when we were completing estimated weight food diaries with children, we used food portion images that were designed for use with adults, and we noticed that these really didn't work well with children. As a result, we developed and validated a series of food portion photographs for use with children. And these include 104 foods with images for estimating the amount served and the amount left over, and guide images for foods that foods like cakes, which come in predetermined amounts. The photographs were validated in a feeding study where we served children foods to consume for breakfast, lunch, and a snack at school, and weighed any leftovers. And then they were further tested against 4-day weighed intakes with estimates of portion size made on day 5. Both the parents and children were interviewed separately to obtain portion size estimates of the photographs. Portion size estimates using the photographs. The key findings were that the mean intakes for energy and macronutrients were within 5% of the weighed intake values. And the limits of agreement, that's the range within which 95% of the estimates will lie, were between an underestimate of 40% to an overestimate of 58% of the weighed intakes. And perhaps most importantly, by 11 years of age, we found that children were as accurate and precise as their parents in telling us about how much food they'd had. In addition to the book of food photographs, we had a computerized version of the photographs, which were linked to food composition codes, as well as portion sizes. And in 2010, we got funding from Food Standards Scotland to develop these into a self-completed 24-hour recall. The system's based on the multiple path recall and is structured with commonly consumed meals and snacks. It's similar to ASA24, but it doesn't collect as much detail as it was intended for self-completion by children aged around 11 years and over. The foods are typed in using a free text search, and there's a separate section for entering drinks to help people to remember to include them in their recall. The system provides possible matches for the search term, and these are linked to our nutrient composition codes. As the system was developed for use with children, we've kept the food list quite short and simple so as not to overwhelm them by asking for details that they can't give. For foods like bread, portion size is selected from a range of common sizes, and then the number of slices is recorded. For foods like pasta, rice, or beans, there are a selection of thumbnails which the respondent can click through to select the image that looks most like what they had or their child was served. And we've included a number of different options for portion size estimation to try and make it as easy as possible for participants. For drinks, there's a sliding scale to indicate fill level on glasses and mugs. And there are also questions to check for commonly forgotten foods and foods consumed together, such as milk and tea and butter on toast. There's a same as before option, so if somebody has the same drink several times a day, they don't need to fill in the details each time. And there are checks for any long time gaps to make sure that people haven't forgotten about snacks or drinks that they've had. Additional questions can be added, and here they're being used to ask about where the food which was eaten came from, but they could be used to collect information, for example, on supplement intake. So Intake 24 has been successfully used in assessing the Public Health England Sugar Smart campaign with children aged 5 to 11 years, with the parents and children completing the recall together. It's also used in the UK National Diet and Nutrition Surveys with all age groups, and in the Scottish Health Survey with ages 11 years and over. There's a website if anyone's interested in finding out more information, which has links to publications. It's also open source, so there are links to things like the food photographs. The system's been developed for use in Australia, Portugal, Denmark, United Arab Emirates, and South Asia. And I'd just like to finish by leaving you with this photo of my son. This was taken when I was keeping a weighed diary for a colleague. And as you can imagine, I was only able to give her a very rough idea of what he actually ate. He's a little younger than 6 here, but I think it nicely illustrates that we need to acknowledge the limitations we're working with and to have realistic expectations of the accuracy that we can achieve when trying to assess dietary intake in young children. And finally, I'd just like to acknowledge that the work presented was conducted at Newcastle University, and to thank the many colleagues who contributed to this work. Thank you for listening, and I will now hand over to our next speaker, Tracy Beckelman. Sorry, just working out how to stop sharing screen.
Okay. Good morning, everyone. Thanks, Emma, for that great talk. Are you able to see my slides?
Yes.
Yeah.
Great. I'm Tracy Beckelman. I'm a fellow at the University of Colorado, and I want to start by thanking the organizers for the opportunity to present at this webinar. I'm excited to share some work that we've been doing as part of the ECHO program, in which we compared 2 technology-based measures of full-day dietary intake among school-age children, the remote food photography method and the ASA24. Our project was based on the idea that we don't yet know how to best measure full-day dietary intake among school-age children. And to advance the science in this area, we need to identify the tools that maximize accuracy while simultaneously minimizing participant burden. And we also need to identify challenges to dietary assessment that are unique to school-age children, and then figure out ways to overcome those challenges. In 2019, we conducted a study to compare these 2 dietary assessment tools with the focus on identifying potential sources of misreporting and participant burden. The first tool was the remote food photography method, also known as the RFPM. As part of this method, participants photographed food selection and plate waste with an iPhone, and the images are converted into estimates of energy and nutrients, and then intake is calculated as the difference between the 2 photos. This is all done through a phone app developed at the Pennington Biomedical Research Center at Louisiana State that allows participants to provide some details in addition to the photos, like food descriptors, for example, labeling a cup of milk as non-fat or low-fat or whole, also details on eating location and food source. And I think some of the strengths of this method are that participants don't have to recall past intake from memory because the photographs are taken in real time. And they also don't have to estimate portion size because a trained researcher does this in the lab with specialized software. The RFPM also has several features that are designed to reduce misreporting and burden. One example is text reminders that are customized to the participants' usual meal and snack times to remind them to take the photos. The second tool was the automated self-administered 24-hour dietary assessment tool, also known as the ASA24. We use the 2018 version, and this is a web-based dietary recall where either respondents, or in the case of our study, a parent proxy, report intake on the preceding day from memory. And the respondent website includes features also designed to maximize accuracy and minimize burden. Some examples are a searchable food database with more than 7,000 items, images that allow respondents to estimate portion size, standardized prompts for frequently forgotten foods, and branching logic to streamline reporting. And the ASA24 is frequently being updated with new features. In fact, since we completed the study in 2019, there is a new version of the ASA24, version 2020. So as part of our study, 40 children aged 7 to 8 years and their parents completed 2 3-day dietary assessments 1 week apart, one with the ASA24 and one with the RFPM, and they were randomized to the order of assessment. After parents used both methods, a parent survey evaluated perceived burden with each method. We then conducted focus groups with parents to identify any barriers to accurate reporting and their perceived sources of participant burden. Finally, we conducted individual interviews with school staff to identify opportunities and barriers to assessing what children eat in an elementary school because of course parents aren't around to observe what they eat in school. Our final sample was approximately half female children and half children from underrepresented racial and ethnic groups, and 26% of the kids in our sample had a BMI above the 85th percentile. After trying both dietary assessments, parents completed an online survey. The questions are on the left here. We asked parents, which method would you rather use to record what your child ate for 7 days? 61% of parents said they would rather use the RFPM, while 39% preferred the ASA24. We also showed that a significantly higher proportion of parents thought the ASA24 took more time to complete than the RFPM. If you look at the bottom of the table, you can see that we also used a Likert scale to assess satisfaction, ease of use, and perceived burden. And the scale went from 1 to 6, with higher scores representing higher satisfaction and ease of use and lower burden. In other words, higher scores were better. And we found no differences in the scores by method. We also calculated each child's estimated energy requirement as a benchmark for actual intake. This wasn't a validation study, but we did want to have some sense of how reported energy intake compared to a standard for actual intake. And these results are shown on the bottom left of the table. We compared total daily energy intake with the ASA24 and the RFPM to each other. And then we compared total daily energy intake with each method against the estimated energy requirement. We found that reported energy intake with the ASA24 was 231 kilocalories higher than the EER, and reported energy intake with the RFPM did not differ significantly from the estimated energy requirement. So we collected data from focus groups after parents had tried both methods, and these are their perceptions of the food photography. The things that they liked about the RFPM are in the perceived strength column. They thought that the phone app was easy to use. They liked getting customized text to remind them to take photos at their usual meal and snack times. Parents liked that they didn't have to quantify the portion size, that was done by the research team. And a lot of parents also thought that just the process of taking the photos really provided them some helpful insights into their children's eating, specifically their portion size and the types of food they were offering. And in terms of maximizing accuracy, parents liked that they were able to document intake in real time and didn't have to remember what the child had consumed on the day before. Parents did have some ideas about opportunities for improvement. They felt that taking the photographs was disruptive to some routines, particularly on weekday mornings at breakfast when they were rushing to get out the door, and also some parents thought it interrupted the flow of dinner. Parents of children who snacked frequently didn't necessarily like taking pictures many times throughout the day, and they would have preferred a method in which the workload was consolidated. They had a hard time incorporating alternate caregivers if one parent had the phone and another parent was observing what the child ate. Some parents reported that their children felt embarrassment when they were in the school cafeteria because as part of the food photography protocol, we sent a research staff member to the school cafeteria to photograph what the child ate for lunch. Parents reported embarrassment, although I don't think that's necessarily unique to this method or American culture. And teachers talked about the importance of minimizing disruption to school routines if pictures were being taken at school. In terms of maximizing accuracy, some parents reported that there were just photos that there were eating occasions that they didn't capture, either because they forgot to take a picture or their child wasn't with them, which really got at the issue of unobserved intake, which I think is a unique challenge in this age group because children are old enough to eat unsupervised, but not necessarily old enough to accurately report their own intake. We had similar questions related to the ASA24 for parents. The things that parents liked are in the perceived strength column. They liked that there was a consolidated workload and they could capture all the data that they needed by sitting down at the computer at one time of the day. They liked the structured data entry, including things like the branching logic, where they didn't have to answer open-ended questions. And they thought that the food images were very helpful in estimating portion size. In terms of opportunities to improve, they suggested minimizing the time commitment. The average time to complete an ASA24 in our study was 26 minutes, which I think is very similar to what's been observed in other studies. And then one of the things that parent mentioned was that in the food database, they couldn't find some items that were either ethnic foods or restaurant foods. And I did follow up with the list of items that they gave. Some of them I was able to find, and some of them I wasn't. But I think actually in the newer version of the ASA24, there is now a feature that helps find misspelled foods. And then in terms of maximizing accuracy, parents just didn't have a lot of confidence in their ability to estimate portion sizes. To highlight this point of unobserved intake as a potential source of misreporting, I just want to share these two quotes from school staff in elementary schools. We asked them the question, how much do you think parents know about what their children eat at school? One lunchroom supervisor said, kids tend to throw away unopened food, or they'll just take the whole lunchbox and dump it into the trash. So they go home with an empty lunchbox, and their parents had no idea that they really didn't eat anything except their cookies for lunch. So the take-home points, continued effort to improve the accuracy of both the ASA24 and remote food photography method is justified given their high acceptability among parents. Technology-based measures bring many advantages, but also new potential sources of misreporting and burden. Dietary assessments in which parents or proxy reporters for their children have unique challenges that go above and beyond dietary assessments in which adults self-report. Interpretation of findings in dietary assessment studies really needs to account for the unique characteristics and limitations of each method. This study is an example of how they differ by method, and future research is needed for not only accuracy and parent burden, but also for the cost of the methods, the burden on the child, the burden on the researcher, and the burden on schools. And I'd just like to thank my collaborators, my colleagues in the ECHO program, and the families who participated in this study. And I will pass the screen back to Dr. Debalia.
Thank you very much, Emma and Tracy, for the wonderful presentations. And we are moving now into the Q&A period with members of the Planning Committee and our sponsors from the Office of Dietary Supplements. And I would like to ask my colleagues to raise their hands. I already got 2 hands risen before I'm seeing Anna Maria's. So I'm going to start with Cheryl Anderson.
Yes, good morning, everyone, and thank you so much for those really brilliant presentations. My question is for either of you, actually, and it's about supplement assessment in this age stage. For the things that we might be commonly interested in this age group, what's the best way to go about assessing supplement intake? And particularly, Tracy, I mean, you described 2 really excellent assessment tools and how they performed in terms of energy requirement. Can you comment a bit on those tools, particular for supplements? And then Emma, if as you talked about the broader picture of diet assessment, can you comment a bit on what we might focus on if we were thinking about supplements?
I can start. That's a great question. So we didn't have a gold standard for supplement use, so I can only tell you what they reported. With the food photography, we asked parents to take a picture of the bottle or the multivitamin as part of the in-person training, and I don't think we got any photos of supplements back. With the ASA24, I think when the researcher sets up the program, they have an option to select whether they'd like to ask a supplement question or not. And we did add that question. And we had one participant that reported supplement use on all 3 days they used the method. So we didn't capture a lot of supplement use with these methods, but I don't know if that's an issue with the method or supplement use just wasn't common in this group.
Yeah, I'd say, I mean, we haven't done a lot of measurement of supplements, but I would echo what was said in the first seminar, that actually being able to see the bottles, getting people to bring with them the containers so that you can see what the what the child's been having, and then asking about frequency of use, because I know from personal experience that although I have some supplements to give to my son, they're often forgotten about in the rush to get him out in the morning. So I think looking at the bottles, but then also asking about frequency.
Thank you very much. I want to offer the opportunity for Nancy Pottershman to ask for questions.
Actually, thanks. I don't want to ask. I just wanted to mention that in the ASA 24, there's a list of forgotten foods. And I made sure that dietary supplements was on that list. It's stuff like water and snacks, snack foods. So they do have an opportunity to see it and report it, but perhaps they were tired at that point and decided to just move on and end.
Thank you, Nancy. Anna Maria?
Thank you, Donna. So I had a question because it was obvious in, Tracy, your data, when you were comparing the differences between the calculated EER and then the estimate of energy intake from both using the food photography method as well as the ASA 24, it appeared that the differences really stemmed from boys misreporting. And so I wondered if you could address that. And then I wondered whether Emma, whether you have actually analyzed that in your own data. Did you see a similar observation where you saw differences by sex?
That's a great question. And yes, so we did see differences between the ASA 24 and the RFPM in reported energy intake, and also between each of those methods and the EER. Significant differences among boys, but not among girls. And that was an unexpected finding. I think I'm not familiar with a lot of evidence that suggests that there is sex bias or that accuracy is different in boys or girls. So I think that's part of the reason why we were surprised. And because I think part of the reason is because parents were the ones taking photos. And so, I guess I can't really think of many plausible mechanisms by which reporting would be less accurate in boys, unless maybe they have different eating styles. So I'm not really sure, but I think that's a good opportunity for future investigation, and that could be done with studies with a larger sample size, and also studies that maybe had a gold standard to see if we can replicate those findings.
Yeah, I mean, we found some differences in gender by portion size estimation, but nothing significant. And I mean, I guess you would expect that girls may underreport to a greater extent what they're eating than boys, and that parents may underreport on behalf of their girls, their daughters, than they do for their sons. But we haven't seen evidence of that.
Just wanted to follow up a question from the audience, actually, that asked how old were the children in the study that I presented. They were 6 to 11 at their dietary assessment visit. So it was covering exactly the age range targeted for our discussion today. And we used the food frequency questionnaire to assess their dietary intake. So probably the instrument that has the least accuracy and the highest and the lowest burden as well. Lisa, did I see your hand for a sec?
Yes. Great presentations. And I was wondering, I think this is a question for Tracy about the food images, food photography. It sounds like, so you had staff take the photos at the lunch meal at school. And then I wondered if you could comment on how much time it took to code for, like, say, per day.
How much time it took to convert the photos into estimates of energy and nutrients?
Yes.
So the photos were actually uploaded on a server, and those were all done at the Pennington Biomedical Research Center. So I actually don't know because I wasn't involved. It's a great question. I will say with the ASA 24, you know, the results they're automatic. They come back right away. And when you're having a research staff member individually code the photos, it does take longer.
Steve?
Thanks, Donna. So, Donna, as you indicated at the beginning, this is an age range where a lot of changes are going on. And Emma, I think I heard you say that by age 11, children can be reporting in a similar way to what their parents would report. To me, that leaves open the question about the ages between 6 and 11. And I'm just wondering, when you're looking at that age range, how best to think about these methods?
I mean, it depends how accurate you need the data to be, and it depends how much money you've got. So when we needed to get really accurate data on what children were eating, both for the food packaging study and also for validating the food photographs, we trained a team that went into schools and measured and recorded what the children were eating. It is an issue that, you know, parents aren't there for increasing amounts as the children age of what their children are eating, and so aren't observing it and they can't be expected to give an accurate estimation. And one of the things that we found when we were doing the validation of the food photographs was that in a childcare setting, the staff were able to give us a reasonably accurate report of what was served to the children, but they weren't able to tell us about individual leftovers.
I also have a question, probably for Tracy, but both of you are, or any member of the planning committee or panelists today could jump in. But the question is, now that we're seeing this head-to-head comparison between ASA 24 and food photography method in this age group, have we learned enough to know which one to pick? Or should we continue to, you know, recommend both? And is there a situation when we would recommend one over the other? What do we do with the information that Tracy, you've provided?
Yeah, I think that gets back to a point that a lot of the speakers have made, which I think is really important, that the dietary assessment tool needs to match the question. So for example, the food photography provides all this really unique data on foods offered and plate waste, and that can give us some insight into things like selective eating and food neophobia and portion size offered by parents. And so if you were interested in those types of dimensions, then of course you would choose the food photography because it provides unique data in that area. But in addition to you know, accuracy and burden, and novel features, we also need to think about researcher burden and the funds available for the methods and the burden on the child. And so I think in addition to picking a method that's unique to your research question, you also need to think about how the method relates to the overall resources that you have and how invested the research team is in collecting, you know, accurate measures of dietary intake. For example, if I could just bring in food frequency questionnaires for a minute, if I was doing a study and the primary outcome was total daily energy intake, I probably wouldn't use a food frequency questionnaire, but something like food photography may be able to provide more accurate measures. So I guess my answer is thinking about the question and the unique features of each method. What are some of the disadvantages that you're willing to tolerate in terms of burden or cost, and just the overall resources of the team.
Any other opinions on this? If not, I
do.
Will, yeah, go ahead.
Don't close off. So I still think that we don't know yet. I mean, while I agree with Tracy on some of her, you know, insights there, I still think that the information we have is based on small sample sizes. We don't have enough understanding it with different subpopulations. How generalizable are these methods, especially the newer methods? And given the conversation we had the other day in terms of the digital divide, while the majority of people have iPhones, you know, the ability for people to be able to use these iPhones and be able to transmit the data, I still think we're going to be posed with the question of missing foods, missing eating occasions. And so I would not necessarily move towards that. I think what we're beginning to hear, which is always been, I think, a fundamental principle in dietary assessment, is the fact that having multiple methods for assessing what it is you're interested in is highly valuable. So that if you wanted to use a new technology, have a backup, but also having a biomarker for a particular nutrient that you're interested in makes a whole lot of sense. At least that's my 2 cents worth.
Thank you, Anna Maria. I was going to follow my other question with, let's look back at the example I started with. If we were to design the study today with the information we know today, which is definitely incomplete, as you pointed out, Anna Maria, how would you design it? Question for anybody who would like to address this.
I guess, you know, I think gold standards are important, things like doubly labeled water if you're validating against energy intake, and certainly larger samples that are diverse socioeconomically and by race, ethnicity, so that we can get at some of these questions about whether accuracy and burden vary within subpopulations. And if there was funds to do that, I would love to do a study like that, and also to compare cost and compare researcher burden and compare child burden. And also, I think, finally, really get at this issue of unobserved intake and get a better sense in all different age groups, how accurately parents and alternate caregivers are reporting intake that they didn't directly observe.
Thank you. Erica.
Yeah, I'm really interested in this potential gender difference with the boys and the girls, and whether any of the studies or any of your future studies might incorporate some options like involving fathers, or also video cameras, since we have, you know, we're on this virtual, we have these video cameras and laptops, and, you know, potentially, you know, there are ethical considerations, but potentially videotaping meal times, and what your thoughts are about some of these issues for your research methods.
I can start. I think, you know, as an anthropologist, I think videotaping meal times just provides so much rich data about so many dimensions of eating that can give insight into dietary assessment, but also meal times and parent feeding practices. And so I think that kind of method would be wonderful, but of course you always have to be concerned that people are going to change the way that they're doing things because they're being recorded. And I think there has been some work done with videotaping meal times that came out of France, but I can't remember whose group it is. But I really like that idea.
There was a group at University of Otago, I think, in New Zealand, who had children wear SenseWear for something like 7 days. And they weren't intending to look at diet, but they obviously picked up quite a lot of health-related behaviors in terms of you know, cooking and the sort of environment, whether people were eating with the TV on, whether they were sitting down to a table with family and friends. They were also looking at the advertising that the children were exposed to through the day. As you say, I think, you know, getting it through an ethical committee and the social desirability bias are both issues. And also then obviously the volume of data that you have to pull through, how you pick out from that data what it is you want in an efficient way.
So what about fathers being involved or other care providers? I don't know if any of your studies involved daycare providers, which is we talked about, in the last webinar, but also affects this age group. And fathers, maybe how that would work for the boys reporting.
So we've always done a combined parent-child interview with the younger kids, and we didn't specify who it was going to be, but the vast majority of the time it was mothers that took part. We had one or two dads out of several hundred kids that chose to complete the diary and do the interview with us. In terms of the caregivers, we interviewed caregivers as well. As I said before, the main thing that we noted was that they were able to say what the children had been served with quite a lot of accuracy, but they didn't know how much the individual children had eaten of the food that they'd been given.
Okay, thank you very much for a very nice start of the day with two wonderful presentations and an engaging discussion. We're gonna now move into the second part of this webinar. We're not taking a break today. So I'm going to invite Tom Baranowski to talk next.
Good morning. It's a pleasure to be here. Thank you for involving me. I'm going to talk today about what we call objective passive methods of assessing dietary intake. Please consider what I present as interesting ideas about a possible future method, but is certainly not available as an off-the-shelf method for use tomorrow by anybody who's interested. I would encourage people to try it, but it would be methodologic work, not real-time dietary assessment. So change the slide, please. We've done a series of studies, my group, and then a colleague, Susie Domel, has done even more. In doing this research, we observe what a child eats at lunch at school on day 1, and on day 2, preferably in the morning, we interview the child about what they had the previous day, and then we compare food by food what the child reports on the second day. In our hands, we've gotten roughly 25%, sometimes more, sometimes less, of the foods that the child ate was a forgotten food. And this is the most interesting finding, about 25% of the foods that the child reports are intrusions. We saw what they ate, and they sure didn't eat those foods that they reported to us. There were problems with portion size. The error that occurred increased with the time since the meal. That's consistent with all the psychology literature on memory error, that as time increases from the event, error increases. In our hands, kind of similar to Emma's work, we found that children younger than 9 years of age couldn't provide accurate data with a 24-hour recall. And it was really 10 years of age where we could get reasonably accurate data. And in fact, when we asked younger kids to do a 24-hour recall, some of them started crying. So clearly we need to find methods that minimize this kind of error. Next slide, please. So there are many innovative methods that have been used for quantifying dietary intake. A lot of this literature is in the engineering literature, not in the dietary or health behavior literature. The kinds of things that have been tried are sensors of chewing, sensors of swallowing, accelerometers attached to the arm to detect hand-arm movement. So when the hand moves towards the face, that would be considered an eating event. Lots of people have talked about the active smartphone use. A colleague at Alabama has attached a camera to an eyeglass frame, and the camera takes everything in front of the individual at time intervals throughout the day. Another colleague at Imperial College London has an earpiece that looks kind of like a hearing aid, but the bottom of the hearing aid that extends out from the ear has a camera at the end, and it also takes images at selected time intervals throughout the day. There's this report in the literature that there's a tooth sensor that is implanted within a tooth and can sense biochemical composition of food intake during the day, obviously limited biochemical sensing. There are other colleagues who are trying to assess dietary intake by using continuous glucose monitoring. There's metabolomics that detect other aspects of the diet. And what you want, many of these methods need to reflect what it is that you're trying to measure. What do you need, as other reviewers have said. Next slide, please. So the method that we've used is something called the E button. The image at the left on the top is an image of the E button. The bottom image is what the E button looks like worn. The E button is a wearable chest-worn camera. It's been developed by Minghui Sun and Wenyan Jia at the University of Pittsburgh. They're both engineers. They've been working with the E button for the better part of the last 15 years, so they've developed a lot of experience. The E button incorporates multiple sensors. It's got a camera with a 120-degree angle so that it can detect lots of different aspects of what's being eaten. There's a 9-axis motion sensor that's used to identify images with foods. There's a barometer, there's a temperature sensor, there's a light sensor. At one point, there were 12 different sensors in the E button, but the one that we spend most of our effort with is the camera. Next slide, please. The E button can be attached either to the collar or by a lanyard. In that image in the previous slide, it was with a lanyard. In the research that we've done, the images have been taken at 4-second intervals throughout the day. So in a 12-hour day at 4-second intervals, that yields 10,800 images. That's a fair burden in terms of processing images. The ideal approach to image processing in this objective passive method of dietary intake would be initial encryption of the image as it's being collected, storage locally. At the end of whatever the interval is, either the meal or the day, the images need to be transmitted to a central location. At the central location, the images need to be de-identified to protect confidentiality. And then with the de-identified images, a first pass through the images using artificial intelligence needs to identify that subset of images that have food and require more effort. The second set of artificial intelligence needs to identify what the foods are in those images. A third set of artificial intelligence needs to identify what the portion size is or the amounts consumed are that's in the images. And then another set of artificial intelligence needs to look at any food preparation that was done during the day. And then at the ultimate attempt is to estimate intake, incorporating all the information above. Currently, any image estimation of intake is done centrally at a research laboratory, but ideally it would be done locally immediately after intake so that that information could be used as feedback to the participant in education type programs. Next slide, please. So what's the current status in this ideal processing of images? The artificial intelligence has been pretty good at going through those 10,800 images or whatever it is that a research site has collected, and identified which images, which subset of images have foods that require further attention. Identifying a limited number of, so a problem in identifying the foods, the specific foods, is a bottleneck in this approach to dietary assessment. The literature that I've seen has gotten up to a couple of thousand foods that they can identify. But you know, clearly we all know that there are many thousands of foods, and more work needs to be done to develop that artificial intelligence to identify the huge variety. Alternatively, it may be that what some investigator needs is identifying certain categories of foods rather than specific foods, and maybe the existing technology is appropriate. Again, it depends on the questions that's being asked. Artificial intelligence for portion size, there are 3 different major approaches that I'm aware of. One is a wire mesh that gets imposed on the 2D image. There are a variety of different wire mesh procedures. The different wire meshes get deformed to the perimeter of the image, and then there's an algorithm that quantifies the amount that's within that 3-dimensional wire mesh. A problem here is that we don't know what's on the third side, the unseen side of the image. A second procedure is a dot procedure. This is a procedure that's been taken from what's being done with electronic cars so that electronic cars avoid collisions with other objects in their field of movement. But it essentially takes concentrations of dots, and the concentration of dots identifies the dimensions of the amount of food that's there. A third procedure is to have a matching procedure whereby a whole string of images are taken, and then that exists in a library, and then matches are made between the image that is trying to be estimated with the images that are in this library. And that's really a very promising approach, but requires lots of images with foods that have all sides of the food with images in composites. Another thing that needs to be done is we've done work on food images of food preparation, how optimally to incorporate that food preparation images, how to process that so it gets incorporated into the 24-hour recall is work that still needs to be done. A problem in this area is that at each step in the food processing or image processing process, the errors are additive. So having a really good process at one step doesn't necessarily correct errors at another step. And so high levels of accuracy are needed at each step in the process. Next slide. Hey,
Tom, I think we need to move on to Wei's presentation. So okay. We'll circle back to this in the questions.
Okay,
thanks.
No problem. Thank you so much.
All right, can everyone hear me?
Yes.
My screen, great. Good morning, everyone. My name is Wei Per, and I'd like to start by thanking the Planning Committee for inviting me to speak at this webinar. Before I dive into best practices for measuring dietary intake in children, I want to acknowledge that the concept hinges upon the goal of dietary assessment, and the goal really depends on who you ask. Leading up to this webinar, I asked a few nutrition researchers what they perceived to be the goal of dietary assessment. These folks included a practicing dietitian who sees patients in a clinical setting, a chronic disease epidemiologist who focuses on diet as the primary risk factor of interest and a combination of the two. As evidenced by these responses, the purpose of dietary assessment varies. It may focus on the individual or a population. The objective can be to ascertain absolute or relative intake, and the precision and accuracy of the instrument used to measure diet may be of more or less concern. So recognizing that there are these differences in opinions about the goal of dietary assessment and therefore best practices for this endeavor, I want to disclose that I am a nutritional epidemiologist, so my philosophy skews toward the latter two opinions. In keeping with best practices, I wanted to share this roadmap for nutritional epidemiology studies in order to provide some context for where dietary assessment occurs in the research process. As you can see, dietary assessment takes place pretty early on, so any threats to data quality at this step is going to affect downstream processes. In nutritional epidemiology research, or really any epidemiologic research for that matter, the primary threats to data quality are error and bias. Of the two, error is more benign since it's random and it manifests as random noise that might obscure associations. Whereas bias can be more pernicious and it can skew results either away from or towards the null. I'm bringing up error and bias because they affect the quality of dietary data collected and therefore are important considerations when thinking about best practices. So today, I'm going to give a summary of conventional validated instruments for measuring diet in children while keeping error and bias in mind. And then I'll make recommendations for best practices, including some suggestions for data analysis. So what is the best instrument for measuring diet? Regardless of the age of the study sample, the best instrument for dietary assessment is based on some ideal balance between quality and feasibility. And this is something that has been hinted at and discussed by previous speakers. Quality of the data collected by an instrument depends on its accuracy, reliability, and validity, which are affected by error and bias. Accuracy is how close the measured value for dietary intake is to the true value. So if we conceptualize this as a game of darts, accuracy is the ability to put the dart in the bullseye. And error and bias are both threats to accuracy. Reliability refers to the consistency of results for an instrument when it's implemented repeatedly over time in the same population. In other words, you want to place the dart in the same location on the dartboard each time you play, even if that location is not the bullseye. And error is then the primary threat to reliability. Finally, we have validity, which is the extent to which the instrument captures the dietary construct that it's intended to capture, and that its utility is applicable and relevant to other populations. Accordingly, the largest threat to validity, especially external validity, is bias. The other part of the scale is feasibility, which is practical and affects the instrument selected to measure diet. And thus feasibility and its determinants are drivers of error and bias. Determinants of feasibility include study participant characteristics like literacy, cognitive capacity, and cultural norms. And each of these characteristics have potential to introduce bias into data collected, especially when using self-reported assessments. And again, this was mentioned earlier because social desirability is a huge issue here. In terms of burden, it's important to consider the time and resources available to train study staff and to be aware that interview and survey fatigue can affect the quality of information provided by the participants, which can then introduce error into measurement of dietary intake. And then finally, budgetary constraints will affect the instrument you can afford, and therefore it affects both error and bias in the dietary data collected. With this scale in mind and all the components I just discussed, I am now going to talk about a suite of validated dietary assessment instruments for children. So I'll start first with the FFQ, which is short for Food Frequency Questionnaire. This is a self or interviewer administered questionnaire that queries the respondent's usual intake, anywhere from the last 3 months to the past year. The data collected is the frequency of consumption, typically in the past month, for a pre-specified list of foods and beverages. And some FFQs do also inquire on portion sizes. Strengths of this instrument include its relevance to chronic disease, given that our long-term diet is what determines health for the most part. It's cost-effective, and the data collected are ideal for deriving dietary patterns, which I'll talk about towards the end of this talk. Limitations include the fact that the questionnaires are specific to cultural habits of the sample. This instrument is not well suited to quantify absolute intake. And because this relies on self-reported information, it is vulnerable to recall bias. And this bias is most concerning when it's differential with respect to a food, so social desirability issues, or with respect to a health outcome. Next, I'll talk about the 24-hour recall, which was covered extensively in the previous talks, but this is an open-ended interviewer-prompted recall that queries intake from the last 24 hours. Strengths of this is that it is one size fits all. It gives you detailed intake data, low respondent burden, and no literacy is required for the respondent. But the limitations include the fact that multiple passes are needed to get an accurate depiction of usual diet. And even so, this instrument may not capture episodically consumed foods, such as, for instance, fish, which is eaten usually on a weekly basis. It does require some amount of interviewer training. And because this is also self-report, recall bias as well as interviewer bias can be issues. Now next, we have the weighed diet record. And I put a star above this one because this is considered the gold standard for assessing dietary intake. And it's also the method that's often used to validate other instruments. This is an open-ended self-recorded diet diary, if you will, where the respondents use a scale to weigh portions of foods. What you get is actual intake recorded in real time for a short-term period, and there's no interviewer needed. And theoretically, this approach is free of recall bias, which is why it's used to validate recall-based assessments. However, this approach is limited by the relatively large respondent and staff burden, which is then further compounded by the fact that multiple days are needed to assess usual intake. It is pricey because you have to provide participants with the scales. And finally, recording diet can cause changes to diet. And usually what happens is the participant will either simplify what they're eating or eat healthier than they usually do. And what this does is it removes some amount of meaningful and relevant variability from the data. So the FFQ 24-hour recall and the weighed diet record are the three most commonly used dietary assessment methods in epidemiological studies for children. And I've summarized underneath each column the primary strengths and limitations, what you get with that instrument, and also the burden. I am also going to touch on these other three approaches. So meal observations involve a trained rater who observes the subject during meals and records what they eat to obtain an objective depiction of short-term diet. This sounds great, but primary limitations include the potential for participants to change their eating behaviors because of the presence of that observer, and also that meal observations are not always feasible in out-of-home settings, for instance, in schools during a pandemic. Finally, we have biomarkers and anthropometry, which are different from the others in that these are markers of nutritional status because it transpires from both diet as well as metabolism. While I think of biomarkers and anthropometry as providing supplementary information on dietary intake, there are certain nutrients like iron, folate, and some fatty acids that have reliable biomarkers of long-term intake, which may then be used as an objective assessment to validate instruments that, for instance, rely on self-report. All right, so now that we're armed with all this knowledge, let's talk about best practices. For assessing diet in children 6 to 11 years, the best balance between quality and feasibility is the 24-hour recall. An interviewer-administered recall is preferable to the automated kind, and the recall should cover at least 2 weekdays and 1 weekend day to capture usual diet. The help of a parent or caregiver proxy is recommended, especially for children who are 10 years of age or younger. And the interviewer should be well-trained. And there is evidence that supplementing the recall with informal food records that the child can maintain while at school, or getting a cafeteria menu, can improve quality of the data by giving the interviewer a sense of which foods to inquire on. I also wanted to give a nod to the FFQ, which is a low burden tool that's useful for ranking intake of individuals within a population, which is highly relevant to assessing associations with chronic disease risk. A caregiver proxy is recommended, and the questionnaire should be validated for the age and the cultural norms of the study population. For youth in the US, there are 2 validated FFQs for children who are 9 years of age or older. These are the Block Kids FFQ and the Youth Adolescent Questionnaire. Some studies do suggest decent validity of these FFQs in children younger than 9, especially with the help of a caregiver. Finally, I want to make some analytical recommendations, given that it's not always possible to circumvent error and bias through best practices and measuring dietary intake. My first recommendation is to always account for total energy intake in dietary analyses. There are a number of ways to do this, which I'm not going to get into, but I wanted to share this table which displays Spearman correlations among intakes of several nutrients with one another and with total energy intake among 194 women. The takeaway point here is that total energy intake is positively correlated with intake of all nutrients, including the non-energy providing ones like fiber, vitamins, and minerals. So given that total energy intake is associated with intake of diet components and is also a determinant of most health outcomes, accounting for total energy intake in the analysis not only controls for confounding, which mitigates bias, but it also strengthens causal inference by mimicking an isocaloric dietary intervention. It's also important to be aware that children do display recall bias. For recall-based instruments, children do tend to underestimate intake of certain foods and overestimate intake of others. These are findings from a study of children 10 to 13 years of age. So this is the older end of the spectrum that we're looking at here. And the investigators compared the child's self-report of what they ate for lunch the previous day through a 24-hour recall to what they actually ate based on meal observations. As you can see in table 4, children overestimated intake of calories, protein, and sodium. But as shown in table 5, they somewhat egregiously underestimated intake of foods that most kids enjoy, like cookies and juice, and possibly milk, whereas water is overestimated. There are some analytical techniques to deal with this kind of bias. For across the board over or under reporting of intake, regression-based calibration equations can improve accuracy of results. However, if there is differential bias in reporting with respect to another variable, as we just saw in the study by Rafoul et al., you may want to consider testing and validating new thresholds that are indicative of excessive, adequate, or inadequate intake to remove this kind of bias. And finally, while the approach to analyzing dietary data ultimately depends on the research question, the field of nutritional epidemiology is moving towards assessing dietary patterns or indices rather than individual foods or nutrients, since we eat combinations of foods and nutrients that then interact with one another at the biological level to affect health. So this table shows some findings from the Epoch Cohort, which was mentioned earlier by Donna DeBelia. This is a historical prospective cohort in Colorado for which we have dietary intake data at median age 10 years, and again at age 16 years, which I recognize is outside of the age range of this webinar. And these data were collected using the Block Kids FFQ. So using these data, we characterize distinct dietary patterns at both time points using principal components analysis. Then we examine their associations with hepatic fat fraction, which is a risk factor for many metabolic diseases. We were also able to examine the effect of change in 2 of these dietary patterns because they were consistently detected at both time points. So namely the prudent and the Western dietary patterns. And in a nutshell, we found that increasing compliance over time of the prudent dietary pattern was associated with more favorable health outcomes in youth. So just to summarize, findings from dietary analyses like this one are intuitive and informative for identifying holistic and culturally relevant eating habits, which I and many others here think is especially relevant during childhood, since this is a very important life stage for establishing flavor preferences and lifestyle habits. And it's also a sensitive period for future chronic disease risk. So whenever possible, I'd encourage assessing dietary patterns in children in addition to specific foods or nutrients. And
okay. Thanks, Wei, and thanks, Tom. Two really thought-provoking presentations. So now we'll open this up for panel members to ask questions. And I'll just start. Tom, you know, these new approaches you're describing are really exciting, but I wonder if they raise some ethical concerns in terms of the kinds of recording, et cetera. At a minimum, how do we think about who needs to consent if we were going to use some of these methods? Is it everybody in the family? And then if they're used in school, how do we think about this from an ethical perspective?
So when we've done this work, we've the image gets encrypted while being taken or right after being taken, which protects some information. When it gets downloaded to our site, the images are automatically encrypted so that individual identification is not possible. In terms of consent, we've consented the parent and we've consented the child, and our IRB was happy, maybe not happy, but was accepting of not collecting any other consents because of the procedures, the confidentiality procedures that were instituted in the processing of the images. It wasn't a problem for us.
Thank you. Donna, you have your hand raised.
Thank you, Steve. I have a question for Wei primarily, but anybody's welcome to address the question. To what extent what you've presented as best practices for this age range are actually also relevant for other age groups that this webinar targeted? For example, for younger children or pregnant women. Are there relevant things across? And what are perhaps specific issues to this age range or to other age ranges? Mostly thinking here perhaps of the dietary pattern recommendation that you came up with versus more specific nutrient assessments.
Good question. And my answer is always that it depends on the research question. So, you know, I brought up dietary patterns because it's intuitive and also a realistic depiction of how we eat. But there may be times when you really want to understand what the role of a specific food or nutrient is, because there are clearer ways to make dietary recommendations when it's a single component. You know, characterizing dietary patterns works better for life stages where there's more variety in dietary intake. So if you're looking at a 2-year-old, I am not sure if you're going to get very many meaningful dietary patterns at such a young age. But I think by 6 to 11 years, that's definitely a possibility, and it's relevant for these children. You mentioned pregnant women, and I think they are a complex and important study population. For them, you could certainly look at dietary patterns if that is the question you're interested in. But if you're interested in the role of a specific micronutrient that you know is very important to fetal development, it may make more sense to look at that as well. Just keeping in mind that what your findings are for that specific food or micronutrient is subject to, you know, unmeasured, unassessed interactions with other components of the diet and, you know, other unmeasured confounding.
Other questions from committee members? Wei, I'll ask another question. I know your focus, as you indicated, was more on epidemiologic approach, which I think is the focus of these webinars. But we do have a lot of more clinically focused people in the audience. And I'm just wondering, what is your thought about if you were going to include in your slide of sort of pluses and minuses of different approaches with a clinical lens, how would you, what kinds of recommendations would you make there?
Yeah, well, I think if from a clinical perspective, the goal is to truly assess health status and nutritional status and specific intake, the 24-hour recall is still probably the best option. This was the recommendation of most of my colleagues who are registered dietitians who do this on a day-to-day. And, you know, the weighed diet record is also an excellent option, although it just gets expensive with a larger number of participants in your study. You know, I will say that if I think about, for instance, my children's well child visits, I also see utility for the FFQ because oftentimes what these clinicians are thinking about is what the usual habits are of a child and how that is related to their patterns of growth. And so I think the FFQ could also be a good option, but for clinicians, I can see the preference skewing towards the FFQ, I'm sorry, the 24-hour recall and the diet record.
Thank you. Erica?
Yeah, hi. I want to follow up on the question that Steve just asked. I have another corollary to that, and it has to do with, you know, the methods that you've summarized really nicely and what their strengths and biases are. So I appreciated that. But, you know, your question about, you know, assessing food patterns or diet quality, how do those methods translate into studies that are trying to develop diet quality indices? And a second piece is, you know, if we're trying to if we're trying to assess total sugar and simple sugar intake, is there a way to distinguish naturally occurring sugar proportions versus just refined and added sugar? And how does that affect some of the data you presented for the liver fat? Those two questions.
All right, I'll start with the first one. So how does the dietary pattern results translate to clinical practices?
Your diet assessment methods, how do they apply to, you know, assessing diet quality? That's really the first question.
Yeah, so each method gives you, you know, intake of specific foods and nutrients, and there's an extraction process that's automated and supplemented with a database that gives you information like that. And then when you're trying to assess diet quality, there are a priori indices that can do this. So for instance, the Healthy Eating Index, the Mediterranean diet, the DASH score, these are all examples of healthy eating scores or patterns or indices that correlate well with diet quality. And so when you find associations with one such score in an analysis in relation to a health outcome, the way that I think of translating it would be making broader recommendations about overall eating habits of specific foods and food groups that can be used as a guideline when thinking about what to eat on a daily basis.
Is the 24-hour recall the best method to calculate those diet index?
So I will admit, as an epidemiologist, I have less experience with the 24-hour recall. I have historically used the FFQ. But I do know that the 24-hour recall and the data collected by the recall can be used to then derive dietary patterns and indices. There is a method by the National Cancer Institute that is used to process some of these data. Then you can go on and use conventional analytical approaches like the PCA, for instance, to group foods together to get a sense of naturally occurring patterns, or you can use a pre-specified formula to calculate scores that, you know, can then be applied across different populations and can be comparable across different types of populations. And then along those lines, you asked about differentiating between different types of sugars, for instance, like refined versus natural, that type of thing. That is information that you can glean from 24-hour recall and FFQ data. This is information that's extracted at the step of obtaining nutrient composition from the foods. And I didn't talk a whole lot about that, but there is also potential for error and bias depending on which database you choose to use, because the databases are theoretically supposed to be representative of foods in a given country or setting, but that may not always be the case depending on how that database was put together and where the data came from.
I'm muted here. Anna Maria.
Thank you, Steve. So, Tom, I wanted to ask you a question. It's nice to see you again.
Good to you.
You know, we've been in this field for quite some time, and there's been, I said we have been in this field for quite some time. I don't have the gray hair on my face, but we've been there together. You know, we've had grants that have tried to push the field in terms of technology being used in dietary assessment methods. And yet, you know, it seems like we're not hearing that we have made that much progress. And I agree with you that the most sort of significant innovative ideas have really come from working with engineers, because they tend to be problem solvers. And so some of the techniques that you actually presented are really quite novel. But what is it going to take for us to be able to get those types of technologies into a format where we're going to be able to really use them for epidemiological studies?
So we're a good ways away from doing that. I didn't make any presentation saying that you know, you could use this tomorrow. In fact, I had a disclaimer at the beginning. I think that this is a really interesting technology. I think that a lot more development needs to be done. Alternatively, you know, there's at least when we've done 24-hour recalls with children, we've, you know, 50% of the foods are in error, either not reported or reporting foods they didn't have. You know, that's huge. We need to find ways to overcome that. I think taking the images all day long is an important step forward. How do we best process that information is where the effort needs to be expended. We've been using dietitians to process the images. I think that's an important first step. However, you know, we need further development of technology. And is that going to be done tomorrow? No. You know, Rome wasn't built in a day. The e-button wasn't built in a day either.
Thanks, Tom. Amy Herring has a question.
Yeah, I just wanted to piggyback on Anna Maria's question and ask a little bit about, you know, what you would like to see next, because, you know, I can imagine down the road having a button and having the image immediately processed and, you know, the relevant data extracted so that you don't have to save, you know, potentially videos that have other children's faces in them and things like that. And I know that's a long way down the road and a pipe dream, but, you know, if I were a funding agency, you know, where would you suggest I invest at this time in order to make that a reality down the road?
Yeah, so clearly you've got to contact Minghui Sun and Wenyan Jia and further develop the methods that they're trying to develop. You know, unfortunately, it's very difficult to get method studies, measurement studies funded. I don't know what the source of the problem is, but clearly just measurement studies. The measurement studies that have been done are usually a piece of a larger intervention study or a larger some other kind of study. And while that's important for advancing the method a little bit, it would be nice to see substantial investment in the measured development itself. Minghui got involved in this, when the ACA, the National Cancer Institute funded method development studies. The ASA 24 came out of some of that early work. Minghui got his stuff started. Carol Bushi was able to advance some of her photo stuff. So there's, it seems to me that there was enormous advances made at that early funding. We need another round of funding like that to continue the development. You know, there's huge advances being made in artificial intelligence right now. The artificial intelligence that I'm involved in another study working on screen media use and using technology to estimate screen media use. And in that study, artificial intelligence that we're using today wasn't available 6 months ago. And it's a huge step forward in the accuracy of the methods that we're trying to do. So it seems to me that, that there's lots of things that can and need to be funded in just the basic development of the method, rather than developing the method as a subsidiary to another research interest.
Let me just follow up on that. What's the team going to look like of investigators who need to be working on this? Because it strikes me that it's not the usual suspects.
So the teams that have been used, that have been developed, have been engineers who are familiar with the literature on the technology end of this stuff, big data people who can handle huge amounts of data, regular statisticians who know how to convert the big data to meaningful tests of hypotheses, dietitians who are familiar with diet. I think one of the major steps that can be made in this area is incorporating images of food preparation in the home and incorporating the food preparation information into the estimates coming out of the 24-hour recalls or whatever other diet assessment procedure are done. So we probably need grocery store type people who are familiar with products and preparation. One of my collaborators is a dietitian who's also a cordon bleu trained chef who brings very important skills to the task. So I think that it's a huge variety and not necessarily the folks who have been around the table initially.
Thanks.
And I'm a psychologist, so I wouldn't mind a psychologist or two being involved as well.
Okay. Amy, you have a follow-up?
Yeah, I did have a follow-up, and it's just an observation that many data scientists exist sort of as parasites at worst, but in a mutually beneficial relationship at best. And I think to the extent to which we could have images or videos posted in publicly accessible places like a Kaggle competition or something like that, I think you could get some amount of free labor. I'm not saying this is how these methods will be developed, but I think you could at least raise interest and get people engaged if there were data sources easily accessible and available, because I'm so tired of seeing machine learning talks where they're training on the numbers 1 through 9, you know, and it's not that data scientists are not creative. It's just that it is very difficult to access relevant data sources. So this could be, you know, an opportunity.
That's not my end of the business. I know that there are large databases of food images, and I know that many of the artificial intelligence algorithms are being trained on that. The problem, or one of the problems, is that most of those images are images of foods available in stores or in restaurants, and a big problem in food intake assessment is food left at the end of the meal. It's not in standardized sizes. It's usually in odd shapes. Our portion estimation procedures aren't very good at estimating the volume in those situations. And there's just lots of additional complications that need to be addressed.
Yeah, I think Emma's picture of her son
yes,
characterizes that really well. Okay, thanks. This has been a really great discussion. I want to move on to include some audience questions and really broaden the discussion to the group as a whole of presenters. So one issue that has come up is that, you know, obviously measuring intake in schools in this age range is critical, but that raises the seasonal issue of kids aren't in school all year. And I didn't really hear much discussion about how to deal with that in terms of timing of measurements and other kinds of things. So I wonder if Emma and Tracy, if you have any comments about that.
Yeah, can you hear me okay?
We can.
Yeah. So we've done studies where we've been trying to look at sort of usual intake, and so we've measured intake throughout different time points in the year, and we would use the same method. So we would do a weighed diary, but with the parent completing it, hopefully with the child with them during the holiday period. So we've relied on the parents for any time that they're not at school, and then we've done in-school observations when needed.
Tracy, any comments?
Yeah, I guess I would just add to that I think there is some evidence that children's lifestyle behaviors do vary between the academic year and the summer, and that's true for diet and physical activity, screen time, and sleep. The study that we did was conducted just in the academic year for exactly that reason, because then you don't know if the differences are due to the summer vacation or the school year. Adding in summer vacation, I think, could potentially exacerbate some of the issues we've talked about today, because you're just adding in another alternate caregiver, which may be, you know, a summer camp provider or a different daycare provider. And so I think that's definitely an issue, the seasonality that merits further discussion in the dietary assessment literature.
Thanks.
And Steve, I would like to add that, in fact, it also depends on what question you're asking. We keep re-emphasizing that, but it's really an important point, because if you're wanting to understand, you know, from an aspect of how to improve that child's dietary intake, and the child is spending most of the time with the parent and the parent is the caregiver, then you're going to want to assess what's happening in the home. If you're trying to understand a broader perspective on how that child is eating and their nutritional habits, then understanding how that child eats both away and in the home is going to become part of the picture that you're going to want to gather. So I really do think that, you know, once again, the research questions are important. And if you really want to get a more holistic, you know, picture of what that child is eating, then you're going to need to take into consideration seasonality. You're going to take into consideration the multiple places that that child obtains foods from.
Yeah, I was going to say the same thing, that I think that the discussion today is going for me in the direction of, are we interested in the habitual intake of these children in relation with future health down the road? And what are the most accurate methods to obtain that information, versus are we interested in, you know, what happens precisely over a 24-hour period, in which case we might need to take photographs every 4 seconds, or in specific nutrients, in which case we need to come up with accurate methods to measure that nutrient. So it's really different things that we're interested in, but accuracy is important to both. And I think that accuracy is going to be related to both aspects actually in different ways, or our approach towards accuracy might be different when we think about wanting to assess habitual dietary intake, whether versus a specific nutrient.
Thanks. one of the audience members asked about dietary assessment from a global health perspective. And I think what they may be getting at is dietary assessment in developing countries where some of the issues may be different. Certainly some of the foods may be different. Does anyone have experience or want to comment on what that might look like?
We've got, there's a group of colleagues who are testing the technology-based methods in Ghana, and I think Tanzania, but I know Ghana. And the challenges there are, I would put it, overwhelming. So for the e-button to work, you need a stiff shirt so you can put it on the collar. Many of the shirts that are available in Africa are very loose-fitting shirts, and so it leads to very loose cameras, which presents a problem that can be overcome in part by the lanyards, but you can't attach the e-button to the loose shirt. They've got problems of food is not often served in bowls, so identifying the initial portion is challenging. Often the food is eaten by handful, so it goes from the pot to the person's mouth, and that presents enormous problems for portion size estimation. And when that gets fed to the child from the parent's hand, virtually impossible. So the third world presents huge challenges that, to my knowledge, haven't yet been overcome.
Anyone else want to comment?
Yeah, I would just echo that we attempted to do some work in Tanzania, looking at how we could measure dietary intake there. And the eating from a shared pot is the main challenge, I think. The fact that people aren't seeing the portion that's served them, or the portion that's served to their child, and then the portion that's left, that it's all in a pot and it's hands going in, and therefore estimating the amount that any individual has had from that shared pot is exceptionally difficult. We also had issues in terms of getting recipe details from people because they didn't have scales to measure the amounts that were going into their recipes. So we were looking at, how do you estimate the amount of individual ingredients that are going into a dish if they're not using sort of household measures and they're not using scales. So yeah, that plus then the issues with technology and access to technology and internet connection makes it really, really tricky.
I would add in an added challenge to pile on here is actually having food and nutrient databases that have the foods and nutrients consumed in different countries. And so, I've been working with Nigeria and Brazil on some projects, and it's, paper and pencil records or recalls because of technology issues. And then leveraging local databases, leveraging, US or other databases to pair with local databases to ultimately be able to estimate food and nutrient intake.
I also just want to add the nutritional epidemiologist perspective, where I'm usually using a food frequency questionnaire, which does require some cultural knowledge on the study population of interest. And that, of course, gets challenging in developing country settings, especially if there's very little information on dietary practices of that particular population. And so listening to everyone's responses makes me think about how interdisciplinary dietary research really is, right? Like I've heard nutritionists, data scientists, engineers, and I'll say, giving a nod to Tracy Beckelman, even anthropologists who can first do that groundwork to help us understand what foods should we be including on a food frequency questionnaire, given that we can't always be calling these people to ask them what they ate. They can't use computerized processes. And so, along those lines, I can actually see a role for some of these newer technologies that rely on images or these passive methods of assessment to inform what we think of as the more traditional kinds of assessments like the FFQ. And it can really go both ways.
Thanks. So a more technical question. Someone talks about having difficulty measuring the intake of whole unprocessed foods, especially eaten outside the home. Wei, do you want to comment on that one?
What exactly is the question? Like knowing when something is processed?
Well, characterizing intake of whole unprocessed foods, especially school meals, that sort of thing.
Okay. Well, speaking as someone who's seen a lot of FFQs, there are nuances in how the foods are described. So, for example, it doesn't just say potato. It'll say potato and then underneath fried, whole, mashed with versus without butter. And I think that kind of detail can give you a sense of which foods are being consumed whole versus processed. And some FFQs also include information on fast foods, so common ones like hot dogs, burgers. Obviously, the granularity might not be there depending on what specifically the question is.
Great, thank you. This has been a great discussion. I want to make sure we leave time for Cheryl to wrap up. So I'll invite Cheryl to come forward and wrap this up for us.
Thank you very much, Steve, for beautifully facilitating today's conversation. I want to say a hearty thank you to our speakers for this morning. We had Doctors Emma Foster, Tracy Beckelman, Tom Baranowski, and Wei Pern give us a lot to think about as we want to understand best practices in the 6 to 11 age group. Just some take-home points, top line. This is a transitional age group where heterogeneity and cognitive capacity for reporting has to be taken into account. In the earlier stages of this age group, we rely on proxies, parents, often multiple caregivers, people are in multiple locations. And at the later ages, 9 to 11, relying on the child given our belief that they are cognitively able to report. Some of the challenges that came up this morning were around unobserved intake, how accurately the reporting is that the proxy didn't directly observe, needs to be taken into account. Forgotten foods. We were reminded that the 24-hour recall has a feature that allows us to go back and probe for forgotten foods and for supplement use. Also, portion size determination can be tricky. I really thought the conversation around this in a global context was quite rich, and how we might need to think about that when we are moving beyond US borders. Underreporting and social desirability bias also comes into play. The choice of the tool and the analytic approach that is taken, it came up over and over, really depends on the research question at hand. Are we looking at habitual intake and what that means for long-term health outcomes? Are we thinking about assessing precisely what is happening over a 24-hour period? Or do we want to know about a specific nutrient, right? And whatever that overall goal is will really impact what tool we choose and what approach we take. We also have the issue of burden to both the researcher and the participants, the level of accuracy that we need. Do we want to just get people into the right quartiles, being able to rank them appropriately? Or are we talking about needing precise intake? And then I loved the statement about what are we willing to tolerate in terms of the potential disadvantages of whatever method we choose. And of course, all of this relies on the resources that are available to us. I think we can all agree that multiple methods of assessment can be valuable. We really want to try to ensure that if we have these multiple methods, collect something that allows us to validate, thinking about how accurate we can be within the population we're studying, as well as for subgroups within the population, keeping an eye on the digital divide when we're using things that have bits of technology to them. And we want to also balance the quality and feasibility. We have a long way to go with regards to thinking about some of the emerging technologies. We heard about the E button today. and the need to really invest in how we process images, and doing that over time with colleagues from transdisciplinary teams, including transdisciplinary teams like our engineering colleagues and even our anthropology colleagues. And then lastly, I just want to say that the discussion around error and bias I thought was quite rich. It affects the quality of the dietary data that we collect, and it's really important when we think about best practices. So we want to, with regards to quality, be focused on accuracy, reliability, validity, and around feasibility, thinking about our study participant characteristics, literacy, the cultural norms of that population, time and resources, burden, survey fatigue, and of course, our budget. So today's discussion certainly left me eager for one more webinar on this topic, and I hope you'll join me and our planning committee on Monday, May 24th, when we'll talk about innovations and special considerations in assessing dietary intake. We'll bring back in the conversation on pregnancy, and we'll cover the age ranges of 2 to 11. So thank you, everyone. It really has been quite a delight to have this conversation with you this morning, and we hope to see you next week.